Hey everyone, welcome to my channel. Aditya here. Till now, we have covered comprehensive AWS course. We have covered about so many topics. The last topic we have discussed is AWS destinations. So, in this session, we are going to cover AWS Lambda, IAM roles, and resource policies. Here is a typo, it's resource based policies. So, we'll see what is this IAM roles and resource based policies for AWS Lambda. So, in the previous session, right, we have already seen Lambda execution role in action. So, this IAM role is nothing but Lambda execution role, which we have used in AWS Lambda sessions. So, now we are going to explore it in detail. Okay, so first we'll see the difference between IAM role and resource based policy. So, the difference is we use this IAM role or Lambda execution role, right, is used by Lambda to access other AWS services. For example, we have Lambda and Lambda want to access or send message to SQS, right? That is another AWS service. Or Lambda want to send data to the DynamoDB, that is another AWS services. So if Lambda want to access another AWS services, Lambda should have this IAM role, and inside the IAM role, we should specify this service we want to access from the Lambda. So that service information we will provide into that role. Okay. So that is the use of IAM role. The other one is the resource-based policies. So the resource-based policies is used to grant access for other services to access Lambda. For example, I have S3. From the S3, I want to access Lambda. So in that case, from the S3, I want to invoke the Lambda. So in that case, I could use this resource-based policies, and by using this resource-based policies and attaching to the S3, S3 will able to invoke Lambda. So that is the major difference between these two. IAM role is used by Lambda to access other services, and resource-based policies used by other services to access Lambda. Okay. Now we'll see about the execution role, that is nothing but the IAM role. So for these execution roles, right, AWS provided few managed policies. So we have some managed policies in AWS for Lambda. So here is also a typo. This is not policies execution roles, we can say. So we have some managed execution roles in AWS for Lambda. Okay. So most of the services we are not actually required to create a role. Instead, we can use an existing one, for example. So what I'm going to say here is AWS itself provided some execution roles for different services. For example, for SNS, we have different execution role. For SQS, we have different execution role. So like that, AWS provided some managed execution roles itself. You could leverage it instead of creating by your own. If you want to create by your own an IAM role separately, you can able to do. But for time being, this execution roles, this managed execution roles will be useful for you. So we'll look into it. What are the available managed execution roles in AWS? So these are the execution roles we have. So we have some managed execution role in AWS, right? That is AWS Lambda basic execution role, AWS Lambda SQS queue execution role, AWS Lambda DynamoDB execution role, AWS Lambda Kinesis execution role, AWS Lambda VPC access execution role, AWS X-ray daemon write access. So these are all the few Lambda execution roles that is managed by AWS. So for these services, I think you don't need to create an execution role by yourself. You can leverage these roles, right? So the AWS Lambda basic execution role will be used by AWS Lambda to access CloudWatch to logs into the CloudWatch. The other one is AWS Lambda SQS queue execution role, which is used to send messages to the queue. Similarly, for the DynamoDB, send to store data into the DynamoDB. And also we have Lambda Kinesis execution role to send streams to the Kinesis. Similarly, we have VPC and X-ray daemon write access. So these are the So these are the basic execution roles or managed execution roles available in AWS. So you can leverage them. Okay. And here I missed this best practice. If you see this best practice, create one execution role per function instead of reusing the same for different Lambda functions. So for example, if you created an execution role for a Lambda, then for another Lambda, instead of using the same role, better you can create an execution role for another function also. Okay, that is the best practice provided by AWS. So you could follow that. And we have already covered what are the managed execution roles available in the AWS also. Now, if you see the last point, the good example for usage of roles, right, where we used this execution role is event source mapping. So, do you remember what is an event source mapping? Event source mapping is nothing but Lambda has to monitor some service and events in the service, right? For example, SQS, it has to monitor the SQS and it has to monitor for its messages, right? So that means Lambda should have access to, or Lambda should have permissions to access messages in SQS. So in that case, you need an execution role. For example, here you have a managed execution role called AWS Lambda SQS queue execution role. You could use this role so that Lambda able to access queue and get the information. Okay, so that was the use of Lambda execution role. I think we are good with it, and I am moving to the next topic, that is resource-based policies. So as we discussed earlier, what is the use of resource-based policies? Some other service, not the Lambda, right? Some other service want to access Lambda or wants permissions to access Lambda or invoke some Lambda function. In that case, we need resource-based policies. So if you see this point, this is required when other services like S3, SQS, etc. want to access Lambda function. So for this type of access, right, for example, we are saying S3, SQS wants to access our Lambda, right? So with respect to access, we have two types of access. One is user access. So usually user access means from the console, if we are able to access the Lambda. For example, I can open the console itself, I can able to invoke the Lambda, test the Lambda, right? So at that case, behind the scenes, I think from the console, we can not able to see what is happening under the console, but behind the scenes, what is happening, user should have an IAM policy to access Lambda. So in case of user, it requires an IAM policy, not resource-based policy. Okay, because he's a user, and if we attach an IAM policy to the user can able to access the Lambda. Otherwise, in service scenario, right, this is only for user scenario. If you see at the service point of view or service scenario, from one service, for example, S3, SQS, etc., to access other service like Lambda, we need to attach or provide resource-based policy. If I attach a resource-based policy to S3, SQS, right, then they were able to access or invoke the Lambda functions. So that is the basic difference between these two access, right? User needs IAM policy, but a service needs resource-based policies to access Lambda. Okay, so here I have written an example. In S3 event notifications, we have seen that resource-based policy attached to grant S3 to access Lambda function. So in S3 event notification, if you observe, we used resource-based policies to S3 to grant access to Lambda function. Okay. So by using these resource-based policies, another AWS account also, even account also, or AWS services, another AWS services can be able to access Lambda, right? Or other services also. So few services require these resource-based policies. Few services require these execution roles. Okay. So based on that, we need to identify which service require execution role, which service require resource-based policies. Based on that, we need to provide that information. Yeah, that's it about the difference between the execution role or IAM role and resource-based policies with respect to Lambda. Okay. Until now, we have seen Lambda's permission and theory, but now we are going to see it in act. So we have seen the difference between IAM roles and resource-based policies with respect to Lambda. Now in hands-on, right, we'll go and check our previously created Lambdas and what are the permissions we have added there, and what is the execution roles we have added, and what are the resource-based policies we have added. We will have a look now. AWS console. Okay. From the AWS console, you can do. So I'm just going back. I have already opened my AWS console. So I'm going back. So here I'm going to my Lambda. So I have two Lambdas, right? So from these Lambdas, I will open one Lambda. And if I go to this configuration section where I have this permission section, you can able to see a role here. So if I click on this role, it will navigate me to the IAM console. So this is Identity and Access Management. That is IAM console. In this console, for this particular role, what are the policies attached, we can able to see here. So if you scroll down here under the policies tab, you can able to see the permissions. So I can open this document like this. And if you see here, this is AWS Lambda basic execution role, which we have already learned, right? We have already discussed in the theory section. So if you see this AWS basic Lambda execution role, and you can able to find out what is happening here. This policy is saying a statement, and inside the statement, you have multiple allows. For example, you have allow create log group. So this Lambda was able to create log group. Okay, that is one thing. And the second thing is it was able to do these actions on this log group, like adding log streams and also log events. So this is, as we discussed, this is AWS basic Lambda execution role, which will give access to the CloudWatch to put our logs into CloudWatch. Okay. So this is about the execution. And if you want to see where is our resource-based policies resides, then you have to go to Lambda. So I'm going to my Lambda, 6784 Lambda. And if I go to configuration section and go to permissions and insert the permissions, if you scroll down below, you can able to see your resource-based policy statements. So this resource-based policy statement is not available for all the Lambdas. Okay. These are available for Lambdas which require access from the other resources. For example, this Lambda is accessed by S3. So S3 enabled the event notification feature to invoke Lambda so that only you will have this resource-based policy. But in normal scenario, for example, I'm opening this, right? This is test 6784 event. So if you see this Lambda, if I go to configurations and permissions tab, and I have my role, and also if you scroll down, the resource-based policy is null here. That means nothing is there. So what is the difference, right? When you are going to use resource-based policies, when you are going to use execution role. I think we have already discussed those things. So here the 6784 event is connected to SQS, right? Here SQS is not invoking the Lambda. Lambda is responsible for looking for the events in SQS and it will process those events. But when you see this S3 event notification example, S3 needs to send its events to Lambda to process. So S3 need access to Lambda. So that's why we will add resource-based policies here, but we are not having resource-based policy under this thing because here Lambda is responsible for getting the data from the SQS. So for that, right, previously we have seen the role of S3 event notification Lambda where we have only one permissions, that is AWS Lambda basic execution role. Now we'll move on to our SQS example, the Lambda which is getting the details from the SQS and see how the role was different from the other role, right? This role, I'm opening the SQS Lambda role. And if I scroll down and if you see this permission section, you can able to find two policies attached here. The first one is the earlier one, that is basic policy, basic execution role, nothing but, which will allow Lambda to write its CloudWatch logs. But the other difference is the other execution role, that is nothing but to have access to SQS. For example, if you see here, we can able to access SQS and you can receive message, delete message, and create log group for that messages and put events, right? So this is an AWS Lambda SQS queue execution role. This is another policy attached to this role to access SQS. So this Lambda needs to access SQS, so that's why it's have that execution role. But since Lambda is not invoked by SQS, we are using Lambda to get the events from the SQS. That's why we don't need the resource-based policy. But here in the S3 event notification, S3 is responsible for sending its notification to Lambda. So that's why we need resource-based policies here. And if I try to open, right, we have this view policy option. If I try to open this policy, and we can able to see what is happening inside this policy. So here we are saying we have this Lambda. The effect is allow from the Lambda. Okay. And we are saying invoke Lambda. So yes, from the service S3, we are saying action invoke Lambda. And we are giving the ARN of the Lambda, and also our source ARN should be this bucket. So this bucket, any event happen, we are saying invoke the Lambda. So this is the resource-based policy. I hope you have understand the difference between the Lambda execution role, that is nothing but IAM role, and also resource-based policy, which is having policies to other services to access Lambda. Okay. And yeah, that's it. That's it about this hands-on lecture. And if you like this video, right, like, share, and subscribe, and let me know if you want to learn further more concepts. And thanks for watching my video. Bye.